Hello and welcome to our today's webinar. My name is Vladimir. I'm technical sales manager here at K2. And today we have a special topic, PV installation on a rafter insulation, and a very special guest, Paul. Paul, introduce yourself, please.
Hello, my name is Paul Southcott, and I am a technical consultant working for HECO-Schrauben in Schramberg. And I have been working for HECO now for more than 10 years. And today we would like to show you the difference of how one can fasten systems to on-rafter installation.
Exactly, but as usual, first our rules for our webinar. So if you have any questions, you have two options usually in Zoom, chat and Q&A section. So if you have like general comments on sound, on picture quality, please write it in chat. And if you have questions to our today's topic, please put your questions in Q&A section. It's easier for us to answer it from there. Yeah, and please do it. Yeah, otherwise we will not see your questions. We will be not able to answer them. So let us start. Paul, you want show us something, explain us something about HECO, about your screws, about your company.
Yes, thank you very much for letting us present our products at this webinar. So first of all, I will just introduce the company as such so that you get a feeling of what we actually do. And for this, I'll just swap over to the presentation. So we are a screw manufacturer. Excuse me, here we go. And we've been around since 1888, which means the founder of HECO was a person who started off making a bending device to make sure that the times or the clocks in the Black Forest worked the same way, because up till then time was not the same everywhere, as the clocks kept on turning further or not quite as far. And he invented a special machine to make sure that the clocks always worked in the right direction and that they went not too far, so that the time was the same everywhere. We say made in Europe, which means that our screws, the main screws, are made in Europe, in Schramberg, in the Black Forest. And the Black Forest is known for inventiveness, which means that we as a screw manufacturer always try to make it easier for you on the building sites and to simplify applications. We have been an innovation leader for a long time, and you will also see a lot of special gimmicks on our screws, which you can also find on competitor screws in a similar way. But a lot of these special things were invented by HECO. We are a reliable partner, meaning that we have roughly 770,000 quality checks per year, which means that we try to keep our quality as high as possible so that you always have the best product for whatever you want to do. So, just to have a quick look at what we exactly do. We started off in 1936 with production of screws, and in this run, more or less, one also invented hinges, and to fasten these hinges one needed special screws. This was the beginning of the HECO-Fix chipboard screw. That was in 1978, where one invented a special screw which could be used in any kind of material at that time. We overworked the product as such in 1990 and generated a new special screw, which was the HECO-TOPIX-plus universal screw. In 1995, we invented an insertion anchor for concrete, which is the Multi-Monti. And this screw has also been overworked in 2016, which gives us now the opportunity to present you with the Multi-Monti Plus, which has special qualities for various applications in concrete and masonry. In 2020, we invented the HECO-TOPIX-plus screw, And this screw has further specialities, as we have a magic close effect, we have a grip fit effect, plus we have a perfect pitch on our screws for the best performance in any kind of application. As we say, we are European, we come from the Black Forest, but we also have a second production plant in Câmpiătuți in Romania. And all our easy or simple screws are produced in Romania. All the high quality, the special screws are produced in Germany. But all the screws that we actually sell go via Germany, so that we always are able to make sure that the quality is maintained. So today, we would like to have a look at mounting of photovoltaic systems on rafter insulation. Now, on rafter insulation, we have special properties or special definitions also. What is on rafter insulation? We have soft on rafter insulation material, but we also have rigid on rafter insulation. And the difference is that one material can be compressed slightly, or you can transfer loads via the insulation itself with rigid insulation. And if you have soft insulation material, then of course you are not able to transfer any load via the insulation material. So you have to make sure that the loads can be transferred via the screws straight into your rafter. And this is what we're going to have a look at today, how this works. So we have a special HECO-TOPIX-plus flange head screw. And these screws have the property that, on the one hand, we have this cylinder underneath the head to maintain clearance hole play in the solar hooks. Because if you would take a normal timber screw, you usually find that they have a conus underneath the head, which is all right in timber. But if you're using some kind of metal fitting, then if your insulation material gets compressed slightly, which means that your counterbatten could sink down a little bit, then you would get or generate more play underneath the head, which means that the hook would not really sit tight anymore, and it could start to flap and produce noise. Another very important thing is you need to have a special tip to be able to use the screws without pre-drilling in cases. And this is what we have on our special HECO-TOPIX-plus flange head screws for insulation or installation of on-rafter insulation and mounting photovoltaic systems onto rafters. This special tip enables us to, first of all, start on hard surfaces easily. Plus, we can reduce the insertion torque, which means that you have a longer battery life. You can insert more screws with one battery. Plus, it reduces the splitting tendency of timber. Just to show what I mean, with a normal 8mm screw, if you would insert that into a batten, that's the picture on the right side, you would usually generate a splitting of the timber as you are trying to push a material, say 8mm thick, into timber at 5 centimeters from the end face. With our special tip, we are able to do this without splitting the timber. And this is a very decisive factor for fixing onto counterbattens, as counterbattens have only got a certain width, and to make sure that you can install the screws safely and use the full pull out of your thread in the timber, you have to make sure that the timber does not split. Of course, our screws are have their own ETA, which is the ETA 190553, and you can find all the information you need for any kind of fixation or any application into timber in this ETA. Right. The advantages of this product means that you have a quick starting screw, you reduce your splitting tendencies, you have a high thread pitch for fast insertion. This is always important if you want to perform an application quickly, because where you can actually save time is by performing the application as such. It's not just the price of the screw or the price of a part of whatever you're doing, it's always the whole thing. And that's what actually, or where you can then save time, and that means that you reduce costs. Now, depending on what you want to do, you have various regulations which you have to follow to be sure that you maintain the regulations which are stated in various leaflets or certifications. Now, if you have a normal product, a screw which is certified via the EN 14592, you can perform various applications, but you have to follow the spacings and edge distances according to Eurocode 5. Now, if you have applications which are not regulated or which are not mentioned in a certain leaflet, then you have to have a special ETA or a special certificate which states that you can actually use these screws according to this application and how you can then do the calculations for whatever you need to do. This is put down in the, well, you have regulated products which follow the harmonized EU norm, but then you also have non-regulated products or non-regulated applications. And these are then stated in various certifications like a single certification, or you have a technical general approval, or you have a European technical assessment, which then shows how you can do the calculation for a certain product or for a certain application, and how you can then generate the correct loads for what you want to do. Right. So we have various possibilities to certify screws according to the application we want to generate. What we have to be sure of is we need to make sure that we have the spacings and the edge distances according to Eurocode 5. And if we're not in these special regulations, then we still have to make sure that we are able to use the spacings which are there. And especially on mounting of photovoltaic systems, we always have to make sure that the counterbattens and the rafters have the right size so that we can perform the application according to Eurocode 5 or our special ETA in this case, as here we have the application mentioned as such, showing that we are able to use our products in this application. This means, of course, that as soon as we use smaller dimensions, we have to make sure that we are able to still calculate our screw the way we need to calculate it. If we go via a normal screw, we have spacings which are defined in the Eurocode. Now this means if we do not pre-drill, we have rather big spacings which we have to maintain. And if we do pre-drill, we can then use an 8mm screw with the spacing between the screws with 40mm, which is 5 times D. If we do not pre-drill, then we have to go to 96mm, or if we have soft timber, say we have timber below with a density between 420 and 500 kilo per cubed meter, we would actually have to go to 120mm, which is 15 times D. So that means we need rather big dimensioned counterbattens to be able to use them. This is not very possible on any kind of roof system. Now, depending on which direction we have the load, we have to make sure that we can go for smaller spacings. Our spacings are mentioned in our ETA, which means that we are able to go to very small dimensions according to Eurocode plus our ETA. So this gives us the opportunity to actually go to rather small dimensions. We can use a 6mm screw in with a spacing of just 30mm, or an 8mm screw if we pre-drill with 40mm thickness of the counterbatten or width of the counterbatten. Now this would mean we would have to pre-drill. As we are able to, or we generated tests with our 8mm screws, and they show that we are able to go to a minimum of 17.5mm perpendicular to the grain without pre-drilling. So this gives us the advantage of actually using minimum sizes of components with 45mm by 100. So we can go into very thin components without pre-drilling. And as the solar hooks have a certain pattern of their holes, we have to make sure that we are able to use the pattern of the pre-drilled holes and still maintain our spacings. So here you can see that something went wrong. As you can see, the roof itself slipped about 30 centimeters. It just moved down the roof because what happened here, the workers on site, they forgot to use shear screws, which mean that they only inserted screws under 90 degrees to the roof surface itself. And screws in timber can take quite a lot of bending, but after a certain amount of stress, they can break if there is nothing that can take the shear. And screws can always take a lot of tension, no problem, which means stress in actual direction. As soon as the stress is only shear, then the screw can start to bend and it'll go to a certain extent and it'll break. And that's what happened here. The customer here was lucky. He was able to take the tiles off and just push the roof more or less up again and fix it properly using shear screws. And this is what we're going to have a look at now. Because on roofs, you have wind suction, wind pressure, plus you have the dead weight of the tiles themselves and the additional snow load, which generates a stress on the screws. As we can see here, we have the suction and the pressure of the wind. And then we have our dead weight and the snow load, which generate a shear load on the screws. Now, to make sure that the screw can take this, we install screws under 90 degrees for suction and pressure, plus we install screws under 60 degrees, but we'll show you that in a second. Now, the load decomposition into pressure and suction plus shear forces for compression of insulation material which is rigid means that we have a material which is able to have more than 50 kilopascal of compression. Now, rigid material would be above 50 kilopascals, soft material is below 50. Soft material cannot take any load in compression. So here we have to make sure that the loads are transferred via the screws. And this is what we do with our screws. For rigid material, the use of part threaded screws is possible as long as we just fix timber on the insulation into your rafters. But as soon as we have soft material, then we have to make sure that we use a screw that takes the load in a way that we transfer the shear out of the counterbatten, as we can see here, straight into the screw, and that load is then transferred into your rafter. So, now I would like to show you a short or a model of how we perform our fixation of on-rafter insulation material.
Paul, let me check first if we have.
Yes, please.
Paul, let me check first if we have any questions, so maybe we can answer them right away.
That's a very good idea.
No, we have no questions, so you can proceed with the model.
Okay. So, as we can see here, when we use a part threaded screw and you come to a customer who wants to put a photovoltaic on the roof, you often find that the head of the screws is actually sticking out slightly. Now, it's not because the screw has been turned out or anything like that. No, it's because the insulation material as such can compress by 10%, which means if you have 200 millimeters of insulation material, it can actually be squashed by 2 centimeters. It's still according to the regulations, but that means that your counterbatten will slip down the screw because you've only got a part threaded screw. And that means that the head of the screw is going to stick out. Now, with a counterbatten, there's no big problem here. But as soon as you have a hook mounted on your counterbatten, and that happens, you get a loose hook. This can cause noise. But what is even worse, if you have your tile sitting here and it gets pressed down, you could actually break your tile. And you will not notice that straight away if you have a photovoltaic system on your roof. You'll only notice it after, say, half a year or a year, as you find some black spots somewhere in the ceiling and you're not quite sure where the moisture has actually penetrated your ceiling, because it's always hard to find where water has actually got into the system. Now, what we do with our system is we go ahead and use our our full threaded, well, it's not a full threaded screw, it's a screw with a thread underneath the head. And this thread now can take care of the loads. It holds your counterbatten in place, transfers the load via the thread straight into the shaft of the screw, and then into your rafter. So we sit like this. As we can see here, this hook here is fastened with our HECO-TOPIX-plus Therm solar screws, and they are able to hold a secure and permanent fixation of your metal plate or your alloy plate on your counterbatten, and they transfer the loads of pressure and suction via the screw itself into your rafter. I'll just show you a little experiment that actually proves why we recommend to always use screws as soon as you're on rafter insulation systems with a thread underneath the head. So here we go. Now, as you can see here, got a part threaded screw. Like this, sorry. Just have to find the right position. So, now, when we install a hook with a part threaded screw, what's going to happen? If you check this place here, you can see. Now, we inserted the screw, our fixation is tight, but we already compressed the insulation material. Now, when we use the second screw, We can go ahead and install it. Now we're in the bottom. As you can see, we have now compressed the insulation material still further. We have no connection between the plate and the head of the screw anymore. And we have compressed the insulation material still further. Now we can keep on doing this, but the problem is we won't really get a defined position where we actually know that the screw plus the insulation is not too compressed and our hook is safe. Now, in time, the insulation material can be compressed even more, which means that the hook is going to be loose again. So this is not really a good solution. It would be possible with hard material, but it does not really make sense to do a thing like that. So that's why we recommend to use our HECO-TOPIX-plus Therm solar fasteners with the thread underneath the head. And I'll show you why. So here we go. We take our HECO-TOPIX-plus T solar screw with our thread underneath the head. Now when we install the screw, as soon as we hit the surface, sometimes it can happen that the counterbatten is lifted slightly. The reason why is very simple. As the thread underneath the head is already in the counterbatten, but the screw does not start straight away in our rafter. What's going to happen is the screw is being turned inwards. We have the counterbatten sitting on the thread already, which means it gets lifted up, and the tip of the screw does not penetrate into the rafter straight away. So what one does then, if this happens, you turn the screw backwards, press on your counterbatten, and then insert the screw, and then you have a nice proper connection. Now we install the screw. We have a secure fixation. The head is flat on the surface here. We can go for the next screw. No problem. And we have a tight connection and always safe. And we know that this connection is going to stay safe for the time it should, which is 50 years plus. And on photovoltaic systems, you do not want to check every 5 years if your connection is still in place. So that's why we always recommend, as soon as you are on an on-rafter insulation system, use a screw with a thread underneath the head to make sure that you have a permanent and safe fixture. And then you're safe. So, have we got any questions so far?
No, we still have no question.
No questions? Good. Okay.
Do you want to show something else?
Yes, we'll go for the rest of our presentation here. Right. So what happens when we install the screw? As we saw, we have a slight play underneath the head of the screw if we use a part-threaded screw. Now for timber fixations, that's no problem. But as soon as we are fixing a metal plate onto timber and our insulation material gets squashed slightly or can reduce up to 10%. So if you're using mineral or any kind of insulation material with 200 millimeters thickness, it can actually be compressed to 2 centimeters, which means that your screw is going to stick out. It's no problem in timber fixations, but as soon as you fix something onto the timber, then you will generate play. And that means that your hook is going to be loose and you can generate noise, which you do not really want. So that's why we always go ahead and recommend our HECO-TOPIX-plus T solar screws to make sure that this cannot happen. Because as you can see here, If we have a rigid material, we can insert a part-threaded screw, but in time, this material can reduce slightly, and that leaves the head not really connected with the surface of your batten. Now, what happens is it slides down and the head sticks out. So what we do is we take our therm screws and fix them via the thread underneath the head into the counterbatten, and take the loads out of the counterbatten via the thread straight into the screw and transfer it into the rafter. What we also recommend is, as soon as you place something underneath a tile and you have a metal fitting which you want to fasten onto this counterbatten, we recommend to use stainless steel screws, because especially with on-rafter insulation, you've got your ventilation area, and in summer you can generate rather moist air or humid air in that area, which is around 90% of humidity. And as soon as you have different materials working together, you can generate contact corrosion. And to make sure that this does not happen, we say that one should always use stainless steel screws for any kind of fixation of something underneath tiles or ventilated areas. So the product advantages which we have is the screws are designed for fixation of solar hooks onto counterbattens, no matter if it's rigid or soft material. We are able to make sure that the loads can be transferred via the screws into the rafters and still maintain a good connection between your batten and the solar hook. Our products have an approval which is certified via the ETA. We can make sure that we eliminate contact corrosion by using stainless steel screws. And what we are also able to do is we can do calculations for any kind of system like this. So if you have any questions, or you have some kind of project which you would like to have a verification for, then you are welcome to send this in to our consultants, and we can do the calculation for you. This is what we call our service. We have our own software which you are welcome to use and download for free. And here you can find various systems which we can do various calculations for you, or you can do it yourselves.
Paul?
Yes.
Paul, does HECO calculate also for European countries?
We do calculate for European countries, but what is important is we need to know the wind load and the snow load, because depending on where you are, you can have different snow loads, wind suction loads, of course, and this is what we need to know in advance, because otherwise it's very hard for us to verify a calculation. So this would be important. We have special formulas on our homepage which can be downloaded so that the customers can then put all the input, all the values, the length, the size of the building, size of the rafters, counterbattens, the loads, whatever it is, into the formula. They can then send it to us, and we can then perform the calculation for them.
Thank you.
You're welcome. What we also say is, for a normal roof, if you have an existing roof and you put a photovoltaic system or any kind of weight on a roof, you add additional load. Now, depending on how old the roof is, often you're not able to see what kind of insulation material has been used before you actually place your load on it. So to make sure that nothing happens, we always recommend to use screws with the thread underneath the head, as they are sure to maintain the distance because insulation material is always is only as good as where it is at the smallest part. So if you go ahead and use part threaded screws for a fixation, you will compress the insulation material again, which would reduce the actual insulation itself. So that's why we recommend to use screws with a thread underneath the head to maintain the distance and to transfer the loads via the thread underneath the head into the screw and straight into the rafter without compressing the insulation material further. And these screws can be used for soft or rigid insulation material, so it makes no difference whatever kind of insulation you have. You could always save using a screw with a thread underneath the head for any kind of fixation. What we see here on this chart is that we recommend to have, say, around 4 square meters of any photovoltaic system which you add onto a roof, to place at least another shear screw to make sure that the loads can be transferred properly. Because if you do not do this, then what can happen is you stress the screws too much and you may have some kind of problem, which we would like to eliminate for sure. Here we can see, depending on where the building is, if you're on a mountain or if you're in a valley or wherever you are, it varies. So that's why it's always important to have some kind of calculation so that you know how many screws you will need to be able to have a safe and secure permanent fixation of whatever you want to place on your roof. Especially with photovoltaic systems, you want to be sure that they work for the next 25 years.
Paul, maybe you can show on this model this screw against shearing.
Yes, of course. Here we can see we've got the fixation of our solar hooks. The additional weight, which is now pressing on the roof itself, is taken care by this screw up here. Here we have our shear screw, and the screws here are under tension, which means that the weight is pulling on the system itself. The tension is in the screw here. And these screws would need to be added into the system so that the loads can be transferred properly. Is that?
Thank you.
Good. Okay. So, as I said, we have our service, which means if you need any further information, if you have any questions, or you have a project where you would like to have a calculation for, you are welcome to send it into our Anwendungsberatung at heco-schrauben.de, or you can give us a call. We've got a hotline, so in normal working hours, you will always find somebody to talk to. And of course, you are welcome to send us an email so that we can then perform the calculation for you. If there are no further questions, thank you very much for your attention. I hope it was interesting for you. And should you have any questions later on, you're welcome to send them into HECO or to K2 Systems, and we can then give you an answer. Thank you very much.
Yeah, thank you, Paul. I will proceed showing some features of K2, our software, how to add correct screw. Oh, we have one question. Paul, Venetz probably is asking what about the waterproofness of the roof by drilling such big screws through it?
Right. Well, usually the waterproof system, or when you put down your counterpattern, depending on the roof system itself, you usually have dealt with the waterproof system in advance. either by covering your counterbatten with some kind of folio, or by having a certain system which you can either have some kind of glue which foam or which increases as soon as it gets hard, and that gives you the water tightness. So when we install our system on an existing roof, this has already been done. So there we do not generate any problems. I hope this was sufficient, because usually we do not have any problems with water tightness.
Okay, thank you, Paul. I will show very fast short calculation in K2Base with like main question how to select right screw. Here's our roof. I will not talk about how to design a roof, how to select models and so on. We will just talk about selecting correct screws. Here on the result page, you will have like our fastener. In this case, is our single hook 3S. And here you can select the screw you want to use for your roof. And these 3 screws you will see like rooftop insulation. This means the screw all presented to us with the thread underneath of the head. Paul, maybe you can show us how to define which screw lengths customer needs for insulation?
Yes, we have a, or we recommend to have a minimum embedment depth of 40 millimeters in the rafter. We recommend to use a minimum of 60 millimeters because as soon as you insert the screw at an angle, then you may reduce your embedment depth. And if you insert it at 60 millimeters embedment depth in your rafter, even if you have a certain thickness of your hook, which may generate just 55 millimeters, you're still safe as you have more than 40 millimeters, so the loads can be calculated fully.
Exactly.
The thickness or the length of your screw is usually determined via the thickness of your insulation plus 60 millimeter embedment depth plus the thickness of your counterbatten. Now, should you have any kind of formwork, any kind of sarking boards underneath your insulation material, this is added to the thickness of your insulation material, which gives you thickness of insulation plus any kind of sarking board plus 10 centimeters. That's the length of your suction screw, which is the screw which is inserted under 90 degrees to the roof pitch. And the shear screw is slightly longer, depending on the thickness of your insulation. But this is always, it's always a good idea to check this via the software to make sure that you get the right length.
Thank you, Paul. We have two more questions. First question is about zinc-coated screws. Can we use them with our hooks?
Zinc-coated hooks, we do not recommend to use zinc-coated screws in hooks because you may cause contact corrosion, as I said before. That's why we recommend, as soon as you use any kind of metal plate on timber in that area underneath the tiles, we recommend to use stainless steel screws to make sure that the head of the screws always stays where it should stay and does not fall off after a while. So if you're just inserting the screw through the counterbatten into your rafter, then there's no problem with zinc-coated screws. But as soon as you have a metal or an alloy underneath the head of the screw fixed to the counterbatten, then we recommend to use stainless steel screws. Yes, this is always a question which comes up. How can one estimate the thickness of the insulation material on an existing roof? What one can do most of the times is by going ahead and checking at the eaves how thick is the board which covers the end of my rafter, or I can see my rafter with a bit of luck. Or in some cases, it may be an idea to insert a screw, because as soon as you go through your counterbatten, before you actually hit the rafter, you notice the difference straight away. So that would also be a way to find out how thick the insulation material itself is.
Thank you, Paul. Yeah, the question about stainless steel and zinc coating, I believe we already answered it. Yeah, so HECO has both. Yeah,
Yes.
inox and zinc, and if you use your screws only to connect your counterbutton to the rafter, you can use zinc screw. But if you use a screw in combination with our hook, please use stainless steel screw.
The thicknesses of insulation above 200 millimeters can easily be processed, as we have these HECO-TOPIX-plus Therm screws up to 600 millimeters lengths. So we can go up to a thickness of insulation material of 400 millimeters. It's not usually done, but it is possible, put it that way. But then you would not fix your solar hook into the rafter itself. Then you would go ahead and take, with a bit of luck, thicker counterbattens and then just fix them into the counterbatten as such. But you would still have to make sure that you add the additional shear screws to take care of the load.
Thank you, Paul. Since we have some time, maybe I will show you where to find basic information on screws. Yeah, here's our product catalog page. Yeah, let's go to the start. And here you have to select the system. So for tile roofs, we use single rail or solid rail. If you click on any of them, for example, single rail, and you switch here to download section, roof fastening and accessories, here is our screw manual. Yeah, and here like basic information about screws. Yeah, how to pre-drill, how to install, how deep you have to insert your screw, and so on and so on. So it's very useful. Yeah, it's like basic information on screws. Use it. Yeah, now you know how to find it. We have one more question. How can the roof hook screwing situation be sealed? I believe we answered it already, but maybe you can repeat it, Paul.
Well, to seal a connection through the counterbatten, usually the sealing or the water tightness of the counterbatten has been performed before we actually open the roof. So we're on an existing roof, and here the water tightness has already been taken care of. But what one could do, if you would have to say you would have to take out a part of the counterbatten and replace it, what you could do is either put some kind of water tightness underneath, which would be some kind of a foam, which you would bring onto your counterbatten and then place it on your roof and tighten it. Or you can use various systems which increase some kind of foams work, some kind of plastic or rubber material, which increase and seal the screw or the insertion hole and reduce any kind of risk of humidity in your system.
Thank you, Paul. So we have no more question. I believe that's all what we wanted to show you today, to tell you today, or maybe one more question.
Silicon is not to be used on roofs, because the problem we have with silicon is you would have to make sure that you check the connection after a minimum of 2 years, because silicon can move and it can only, it's not a permanent connection. It's got flexion, so it can still get torn apart, and it can also dry out. So that's why it's important to go ahead and use something which can change slightly and make sure that the water tightness is always maintained. So usually what one does is you have these strips which you stick on the bottom of your counter batten, and you insert your screw through these strips more or less, and these strips have the property that they are able to increase and clog up any kind of holes. So you have a good watertight connection.
So I believe now that's all. So,
We shall see.
Yeah. Thank you, Paul, for joining us today. Thank you all for joining us today to watch our webinar about HECO screws. I think it was very useful for all of you, for all of us. Yeah. So next webinar, Fabian, or is it open date? Okay. So we have no further webinars coming. You can always keep you updated on our webpage about coming webinars, about our trainings and tutorials, and so on and so on. So yeah, thank you all for attention. Yeah, and see you next time.
Yes, thanks a lot, and goodbye.